All right, these are the solutions for version B. We're going to find f of x plus h first. So take the function, replace x with an empty parenthesis. So 2 times parenthesis squared plus 5. The input is x plus h into the parenthesis. X plus h squared, remember, means x plus h multiplied with another x plus h. Multiply x plus h parentheses together, and you have x squared plus 2xh plus h squared. And then distribute the 2. Now you're ready to create the difference quotient. So the difference quotient, just a big long fraction. This expression, f of x plus h, goes on the top left. And you subtract the original function, f of x, and that's divided by h. So the 2x squared minus 2x squared cancel, plus 5, that's a negative 5, those cancel, so you only have these two terms remaining. 4xh plus 2h squared and both terms have at least one h in common, so you could factor an h out of both of these terms, which would cancel out with that h in the denominator, so you would have 4x plus 2h left over as a difference quotient. For part A, to find the inverse, remember you switch the place of x and y, so for part A, I'm going to switch to bx equals, and then y minus 1 instead of x minus 1, so y minus 1 to the third power plus 5. Now we just need to get y by itself. So first thing I'm going to do is minus 5 on both sides. Then divide by 3. Then cube root both sides. And then add 1 to both sides. So finally, y, which I'm going to call the inverse of x, is equal to the cube root of x minus 5 divided by 3, and then a plus 1 on the outside of that cube root. For part B, we're going to have x equals 3 divided by y minus 1. Now we're going to multiply both sides by y minus 1 because that's going to cancel the denominator. So I'm going to multiply the y minus 1 to x, and then when you multiply y minus 1 over here, it cancels with that y minus 1, so you're just left with 3. And then to get y by itself, we're going to divide by x first and then add the 1. So divide by x, and then add 1, and that's the inverse. For question 3, I want to move the 7 over here and just leave these two terms. So I'm going to subtract the 7 and then factor out a negative 3 from these two terms. So that's negative 3 factored out. That leaves x squared. If you factor out the negative 3 from positive 18, that's minus 6x. And then remember the way I showed in class was to leave a blank spot there inside the parenthesis to complete the square. So half of 6 is 3, 3 squared is 9. So this is a plus 9. Now to keep the equation balanced, whatever you've done to the right side, you got to do to the left side. So this is a negative 3 times 9, that's negative 27. So you have to add a negative 27 as well over there. So on the right side, we have negative 3 multiplied by x minus 3 squared. On the left side, we have negative 7 minus 27. That's f of x minus 34. So if you add 34, so now we need to graph. Well, let's take the vertex first. Vertex is 3, 34. So it's 3 units to the right, 34 units up. Now it's definitely not going to fit on our graph here. So like I showed you in video A, if it doesn't fit on the graph, just make sure you label the points with their coordinates. So way up here, we're going to have 3, 34. Excuse me, and then we need to have points on either side. So I'm going to choose x equals 2. 2 minus 3 is negative 1. Negative 1 squared is 1. 1 times negative 3 is negative 3. Negative 3 plus 34 is 31. So x equals 2, y equals 31. So that's 2, 31. And then use symmetry to get 4, 31. So just make sure all of these points here are labeled. When you graph your parabola. Okay, for part A, we need all the factors of negative 3. That forms your list for P. So P are the factors of negative 3, which are plus minus 1 and plus or minus 3. For Q, those factors come from the factors of the leading coefficient, which is 1. That's just plus or minus 1. So then P divided by Q, 1 divided by 1 and 3 divided by 1 is just plus or minus 1 and plus or minus 3. For part B, we can use the factored form that's given to state the zeros. So we have x equals 1, x equals negative 1, and x equals 3. You're going to want to state the multiplicity as well. For x equals 1, that's multiplicity of 2, because it has an exponent of 2. It's repeated twice. Same with x equals negative 1. That one has multiplicity of 2. X equals 3 has a multiplicity of 1. It's not generally stated if you just have a multiplicity of 1, just if you have a multiplicity higher than 1. So those are the zeros of the polynomial. Now for part C, we need to have the intercepts and the correct end behavior. So I'm going to find the y-intercept. If we let x equal 0, then all of these terms containing x disappear to 0. 0 minus 3 is negative 3. So the y-intercept is negative 3. We have x-intercepts. Which 1, 0, that bounces because its multiplicity is even. We have negative 1, 0, which also bounces because it has multiplicity that's even. And then we have 3, 0. That one crosses because the multiplicity is odd. And then the end behavior, because this is degree 5, now the left side is going down and the right side is going up. So on our graph, left side is going to negative infinity, right side is going to positive infinity. Now when x equals negative 1, now we're going to connect the left side up to the right side. When x equals negative 1, it bounces. Comes down here to the y-intercept. When x equals positive 1, it also bounces, so it comes back down. Remember what we talked about in class, if you have a gap between zeros where there's a whole number in between, you need to plug in that whole number to figure out a little bit better idea of how far down that graph's going to go before it turns back up. So when x equals 2, and we're going to plug 2 in for x right here, we've got 2 minus 1 squared, so that's 1 squared. Then we have 2 plus 1, that's 3 squared. And then 2 minus 1, or 2 minus 3 rather, it's negative 1. So we have 1 times 9 times negative 1 equals negative 9. So when x equals 2, y equals negative 9. So it goes down there a ways before coming back up. Question 5, we need to have a third degree polynomial, which means we need to have 3 zeros. So I'm going to start there. The 2 zeros that are given are x equals negative 2, x equals 1 plus I. So then the one that's not given, the one that we need to come up with, is x equals 1 minus I. Next step would be to create the polynomial from the zeros to put into factors. So the first one is x plus 2. The next factor is from this 0. Remember, we're moving the terms over to be on the same side as the variable. So we're subtracting 1, so x minus 1, and we're subtracting I. For the next factor, we're going to subtract 1, but add I. Now next, we're going to multiply these two factors together. So starting with the x, multiplying all three of those terms, x times x is x squared, x times negative 1 is negative x times I is ix. Now we're going to multiply the negative 1 to all three of those terms. So negative 1 times x, negative 1 times negative 1 is positive 1, and negative 1 times I is negative I. Finally, we're going to multiply the negative I to all three terms. So that's negative ix. Negative 1 times negative I is positive I, and negative I times positive I rather is negative I squared. Now, some of these terms cancel out, and then minus I squared is minus negative 1, that's a plus 1. So that plus 1 combines with that plus 1, the negative x and the negative x combine to negative 2x. So we have from that x squared minus 2x plus 2, and then we have this x plus 2 that we need to multiply. So we distribute the x to all three terms. So x times x squared is x cubed. X times negative 2x is negative 2x squared, and x times 2 is 2x, and then we multiply the 2 to all three of those terms. So that's plus 2x squared minus 4x plus 4. And then combining like terms is x to the third. The x squareds cancel, so that's 2x minus 4x, that's negative 2x. And then a plus 4. Now remember, what they're going after is a very specific polynomial. There are an infinite number of third-degree polynomials that can contain these 3 given zeros simply by taking the whole entire polynomial now and multiplying it by any number a. So now we use this initial condition that's given. P of 0 has to equal 8. So the 8 is going to replace P of x. The 0 is going to replace all the x variables. A is going to stay a variable. So 8 equals a times 0 minus 0 plus 4, that's 4. So divide both sides by 4, and we get a is equal to 2. Therefore, the polynomial, if a is equal to 2 and that were distributed to every term, would be 2x cubed minus 4x plus 8. So just to satisfy this initial condition, if all the x variables are 0, do we get 8 out of that when we have 0 plus 8, which is 8. Okay. Again, question number 6, the directions here, write the expression below as the sum or difference. That could be rewritten as expand using several logarithms without exponents. So there were 3 rules that applied. This is, if you go back and look at section 4.4, there's the product rule, quotient rule, and the power rule. Inside this logarithm, we have a quotient, numerator, denominator. So you expand that using the quotient rule, which means 2 logarithms with a minus sign between. So log of the terms in the numerator. Now again, square roots or cube roots, any kind of root and logarithms, you're not going to want to keep roots. So I'm going to change that into the square root of x plus 1. It's going to be x plus 1 to the power of 1/2. So there's your numerator. Now we subtract another logarithm. Now we need the terms in the denominator, x cubed and x plus 3 to the 5th. Now here we have a product. Here we have a product. So this logarithm expression needs to be expanded into 2. This logarithmic expression needs to be expanded into 2 using the product rule. When you expand using the product rule, we use addition. So this will be expanded into log x plus log x plus 1 to the 1/2. These two are going to be expanded log of x cubed plus log of x plus 3 to the power of 5. Now there is going to be a minus sign between, but you have to subtract the entire expansion of this expression with a parenthesis. Otherwise, you're just subtracting the first term rather than both of them, and you should be subtracting both of them because you're subtracting this entire expansion. Last step is just to move exponents down in front. That first one doesn't have any exponents, so that's just log x. This one, the 1/2, comes down in front. I have a 3 in front of this one, and I'm going to go ahead and distribute the minus sign, so that becomes minus 5 log of x plus 3. Okay, question 7. Graphing a logarithmic function. For part A, to find the y-intercept, we let x equal 0. So for part A, this is negative log base 2 of 0 minus 1. So that's negative 1. That's undefined, so there's no y-intercept. Because remember, you can't have a negative number inside of a logarithm. For part B, to find the x-intercept, we put a 0 in for y. So we need to divide by negative So we want the logarithm by itself because we can't use a base 2 until that negative sign's gone. So divide by negative on both sides, but that's just going to mean 0 divided by negative 1, which is still 0. So we have 0 equals log base 2 of x minus 1. If we use a base 2 on both sides, base 2 here means 2 to the 0 power, that's 1. If we use a base 2 here, 2 to the log base 2 cancels out, so you're just left with x minus 1. If you add 1 to both sides, you get x equals 2. Okay. For part C, usually the vertical asymptote for a logarithm graph is right here at x equals 0, but this has been moved to the right 1 unit, so it's at x equals 1. And this is the reason now why there's no y-intercept. The graph of the logarithm function is going to be to the right of this. We have our x-intercept there. The domain is from 1 to infinity. Now we need to sketch the graph, label at least 2 points. So we already have 1 point is 2, 0. Now let me write the function here. Because this is log base 2, whatever is inside this parenthesis, not just for x, but the whole thing needs to be a power of 2. So like this could be 2, for example. If I plug in a 3 for x, I'm going to get 3 minus 1, which is 2. Log base 2 of 2 is 1. 1 times negative 1 is negative 1. So 3 comma negative 1. Now, typically, a logarithm graph looks like this. However, this minus sign flips. This is a vertical reflection, so it flips it vertically. So it's actually going to look like that. That's why we have these 2 points looking like they do, because it's been reflected vertically. Okay, question 8. The exponential term is the base e and the exponent is x minus 1. So we need to get rid of this minus 2 by adding 2, and then we need to get rid of that 7 by dividing by 2. So if you add 2 first, you're going to get 2 times e to the x minus 1 equals 7. If you divide by 2, you have e to the power of x minus 1 equals 7 halves. Now we can get rid of the base using the natural log. So the natural log of e are inverse, so they cancel out. So that's x minus 1 equals the natural log of 7 halves. And then if you add 1, you get x equals the natural log of 7 halves plus 1. And it doesn't specify whether they want the exact form or the approximate form, so I'm just going to leave it in exact form. Okay, for question 9, part A, we want to start in factor form, and it already is. There's 2 factors, so that means we're going to have 2 partial fractions. Now I'm going to multiply each side of this equation by the lowest common denominator, and then multiply here. So those just cancel. Now when the lowest common denominator multiplies the a partial fraction, the x minus 2's cancel out, x plus 1 distributes to the numerator a, so that's a times x plus 1. And then when the lowest common denominator multiplies the b partial fraction, now the x plus 1's cancel out, so x minus 2 distributes to b, so it's b times x minus 2. Now again, with only one equation and two variables to solve for, that's not enough equation, so we need to cancel out part of this equation containing either a or b so we can solve. So if I want to cancel a, I can solve for b. To cancel a, x plus 1 has to become 0. In order to make x plus 1 0, I plug in a negative 1 for x. So I'm going to let x equal negative 1. That's going to be the opposite of negative 1, which is 1. 1 plus 8 is 9. Here, negative 1 plus 1 is 0. 0 times a is 0. So that part of the equation disappears when x equals negative 1. Here, negative 1 minus 2 is negative 3 times b. Divide both sides by negative 3, and we get b equals negative 3. Now that I know b, I want to solve for a. In order to solve for a, b has to disappear. So I can plug in a 2 now for x. The opposite of 2 is negative 2. Negative 2 plus 8 is 6. 2 plus 1 is 3. 3 times a is 3a, and then 2 subtract 2 is 0. So this part of the equation disappears when x equals 2. So we have a equals 2. So if a equals 2 and b equals negative 3, we can write the partial fractions as 2 over x minus 2 plus negative 3 over x plus 1. For part B, we only need to write the form of this partial fraction. So there are three factors. X minus 2 squared counts as 2. X plus 4 is a unique linear factor. So there's going to be three partial fractions, with x plus 4 appearing once. X minus 2 has to appear twice, and remember, the second time has an exponent of 2. And we have the form there of the three partial fractions. We have a system of inequalities we're going to graph. This is a circle. This is a linear. Now the circle has a radius of 10. This graph only goes out to 5. So I'm going to make a couple of changes here. I'm just going to rescale this. Okay, the circle has a radius of 10 centered around the origin. And it's a solid line because it's less than or equal to. And if we use a test point of 0, 0, 0 squared plus 0 squared is 0, which is less than 100. So we're shading on the inside of the circle. Now, the other inequality, 3x minus y greater than 10, I'm going to find the x and y intercepts. So to find the y-intercept, let x equal 0. So if 3x were gone, we'd have negative y equals 10. So y equals negative 10. So the y-intercept is negative 10. Now to find the x-intercept, we let y equal 0. So 3x equals 10. Divide 10 by 3. So the x-intercept is 10/3, which is about 3 1/3. So right about there. This is going to be a dotted line because it's greater than and not greater than or equal to. And then to determine shading, I'm going to use 0, 0. 3 times 0 subtract 0 is 0. But 0 is not greater than 10, so the test point did not satisfy this inequality, so I'm not going to shade towards the test point. I'm going to shade away from it. So I'm going to shade on the right side of that line. So the solution set would be this piece of the circle right here. And then the next part is just identifying the locations of these two vertices. Now we have a pretty good idea one of them is 0, -10. We have to find the other one. We have to find both of these vertices using algebra. So we make our system of inequalities into equations. We cannot use elimination method because these are not like terms. So we have to use substitution method. Now, I'm going to get y by itself because x has a coefficient of 3, y only has a coefficient of -1. So if I'm going to move, actually I'm going to add the y to that side. So this becomes 3x equals y plus 10. Now I'm going to subtract the 10 to the other side. So we get y equals 3x minus 10. So now that 3x minus 10 can substitute in for that y. So we have x squared plus 3x minus 10 squared equals 100. So 3x minus 10 squared becomes 9x squared minus 60x plus 100. If we combine like terms and then factor out a 10x, we get x equals 0 and x equals 6. Now we knew one of them was going to happen when x equals 0. The other one's supposed to occur when x is equal to 6, which is 2, 4, 6 right about here, so that seems about right. We're guessing maybe when y is equal to 8, but we need to find that for sure. So when x equals 0, we have this version for y equals 3x minus 10. So when x equals 0, y equals 3x minus 10. Well, if we plug in a 0 right there, we have 0 minus 10. So y equals -10. So that's the point 0, -10. When x is equal to 6, we have y equals 3x minus 10. So if you plug in a 6 for x, that's 18 minus 10, so y equals 8. So the point is 6, 8. Okay, for part A, I'm going to use elimination method. So I'm going to try to eliminate the y variable. So I'm going to make this into a -6 and that into a +6. So I need to multiply the top equation by 3 and the bottom equation by 2. So this is 24x minus 6y equals 15. The bottom equation is -24x plus 6y equals 14. So now I can eliminate y like I want to do, but x also eliminates. So we have 0 equals 29. 0 does not equal 29, which is an indication that this system has no solution for part A. For part B, I'm going to eliminate y from the top two equations. And then I'm going to take the top equation, multiply by -4, rather positive 4. Let's multiply the top equation by positive 4. So that's 4x minus 4y plus 20z equals -8. That's the top equation multiplied by -4. And the reason I'm multiplying by 4 is I want to get a -4 here and a positive 4 here. So I multiplied the top equation by 4. I'm going to take the bottom equation, y eliminates, and we get 6x plus 18z equals 0. Now I take the results from these first two steps and combine them into a new system of equations. Now if I multiply the bottom equation by -2, x cancels, z cancels, so we have 0 equals 0. That's an indication of infinitely many solutions. So we start then to say let z equal t, and then if we use that middle equation there, 3x plus 9t equals 0, subtract the 9t, 3x equals -9t, divided by 3, x equals -3t. Now, one of the original equations, the middle one, for example, was 2x plus y plus 4z equals 2. So if you can make the substitution now for x of -3t, and then for z, make it t, combine the -6 and 4 to make -2, add the 2t over, so we have y equals positive 2t plus 2. So now we have the values of x, y, and z. X is -3t, y is 2t plus 2, and z is t. For part A, I'm going to set up the matrix equation. Now we need to find the inverse. So that's 1 divided by a times d, that's -12, minus b times c, that's -15. And then the -6 and the positive 2 change spots. The -5 becomes a positive 5, and the positive 3 becomes a -3. -12 minus -15, that's -12 plus 15, so that's 1/3. So there's the inverse. What we would do with the inverse is multiply it here and multiply it here. When we multiply the inverse here, that reduces this coefficient matrix to 1, which is going to isolate this matrix, which is what we want. We'd also have to multiply this inverse right here. So the final step is to multiply the inverse. the matrix 15, 36. Okay, this entry is found by combining this column, this row rather, with this column. So negative 6 times 15 is negative 90. 5 times 36 is 180, so negative 90 plus 180 is 90. This entry is combining this row with that column, so this is negative 3 times 15, that's negative 45. 2 times 36 is 72, so we have a negative 45 and a positive 72, that combines to 27. And then we take this 1/3 into there, so 1/3 multiplied by 90 and 27 means that x is 30 and y is 9. For part B, we set up our matrix equation. And instead of having to go through the process of finding the inverse of a 3 by 3, the inverse is given to us. So really what we need to do then is just take that inverse, multiply by that matrix. So the inverse multiplied by this matrix so negative 3 times 7 is negative 21, plus 10, that's negative 11. Here we have negative 28 plus 5 plus 0, so that's negative 23. And here we have 7 plus 0 plus 0, that's 7. So the solution is negative 11, negative 23, and positive 7. 3 is 12. Okay, determinant of a 2 by 2 is A times D, subtract B times C, so negative 15 minus 2 equals negative 17. For 3 by 3, a little bit different process. So starting from the top left down that direction, 2 times negative 3 is negative 6, times negative 3 is positive 18. Remember, this first 3 rounds we add 2 times 2 times and then negative 1 times negative 2 times 0 is 0. The next 3 rounds subtract. So minus 3 times negative 1, that's 9. 0 times 2 is 0. And negative 3 times negative 2 times 2 is 12. So we have 30 minus 9 minus 12. So it's 21 minus 12. So 9. Okay, for part A, we're finding a sum, and it's an infinite sum. So this needs to be a geometric sequence, which it is. And then the common ratio needs to be less than 1. This is the common ratio. So to use the infinite sum formula, it's first term divided by 1 minus r. We can find the first term by letting n equal 1. 1 subtract 1 is 0. 2/3 to the 0 power is 1. 1 times 2 is 2. And then this is the common ratio, 2/3. 1 subtract 2/3 is 1/3. 2 divided by 1/3 is 6. For part B, we're adding terms together, and 8, 5, 2, negative 1. We're going down by negative 3 every time, so this is arithmetic. So the partial sum of an arithmetic sequence so we know the last term is negative 124, and we know the first term is 8, but we don't know is n, how many terms really are in between here, so that this is the first term, this could be the 20th term, the 40th term, we just don't know yet. So what we need to do is come up with the nth term. So if you look on your formula sheet, the very first one is nth term of an arithmetic sequence. So we know the common ratio is negative 3, or sorry, the common difference is negative 3. So the nth term is negative 3n plus 11. That's the formula that describes this sequence. What we're trying to figure out is negative 124 is which term of the sequence. So we can plug in negative 124 here and solve for n to figure out what number of the sequence it is. So we take negative 124 for a sub n and use the formula negative 3n plus 11 to find the value of n. So we get the value of n as 45. So negative 124 is the 45th term. So now we can use, finally, the partial sum formula, where n is 45, and the first term is 8, and the 45th term is negative 124. And that is equal to negative 2,610. We're using Pascal's triangle for both part A, which is to the 4th power, and part B, which is to the 5th power. So I'm going to use 6 rows. And then for part A, this is to the 4th power, so we actually just need the 5th row for part A, 1, 4, 6, 4, 1. So these are the coefficients. So starting with a 1, 2x is going to be raised to the 4th power, 5 is raised to the 0 power. The next term is going to have a coefficient of 4 with 2x to the 3rd power and 5 to the 1st power. And then 2x squared and 5 squared, 2x to the 1st power, 5 to the 3rd power, followed by 5 to the 4th power. Two x raised to the 3rd power is 8x cubed, so 4 times 8x cubed times 5. This is 6 times 4x squared times 25. This is 4 times 2x times 125. And then 5 to the 4th power is 625. So 4 times 8 times 5 is 160. And then 6 times 4 times 25 is 600. 4 times 2 times 125 is 1,000.
And then 625.
For part B, we need the term in this expansion that contains an x to the 3rd. And since this is to the 5th power, we need the 6th row. In the first term, x would be raised to the 5th power. In the next term, x is raised to the 4th power. So it's this term right here where x is going to be raised to the 3rd power. So 10 is the coefficient. This term 3x is raised to the 3rd power, and the other term negative 4y is raised to the 2nd power. So then that becomes 10 times 27x to the 3rd times 16y squared. So then we need to figure out 10 times 27 times 16. It's 4,320. So 4,320 x cubed y squared.